finished talking about polynomials and functions, and the last thing we're going to talk about are rational functions, which rational means that they make fractions, okay? So over here, here's our example of a fraction instead of just one term or one long numerator. And the thing that is added because of the fraction are what we call asymptotes. And so there are two different kinds. There's a vertical and there's a horizontal. And what asymptotes are is they are the line or lines that a graph approaches but does not cross it. Okay? So they're actually dotted lines, and so the graphs come really close, but they're never going to cross over it. And so you're going to see what we're talking about when we draw it up here on our line, okay? So the vertical asymptote, a lot of times, pardon me, we abbreviate it as VA for vertical asymptote. And it's always going to be, since it's vertical, it crosses the x-axis, so it's always going to be x equals a number, okay? And so that number that we find is when we set the denominator equal to 0, okay? And so we're used to setting things equal to 0, and then we solve it. And we're used to solving it as well. So we're going to do it over here in this example where we've got a denominator, it's going to equal 0, and it's because we cannot have a 0 there, and so that tells us our boundary, that tells us something we can't do, okay? Alright, so then the horizontal, a lot of times we write it as HA for horizontal asymptote, and because it's going across, it crosses the y-axis. So that will be y equals a number. All right, and there's two different scenarios. If the x is only in the denominator, okay? So in the denominator, we'll say only. All right, then it is just that y equals 0. So it's actually, pardon me, our x-axis. It's just a dotted line right here because y is 0. All right, and it's got to go horizontal. If you have an x in the denominator and the numerator, then you divide their coefficients. All right, so if x is in both, then we divide the coefficients. Okay, and that number that we get, that's going to be where we're going to draw horizontal. But we're not going to see that. We're not going to see that in example 1, but we'll probably see it, I think, in example 2 or 3. So here's example 1, y equals 4 over x minus 2. There's the fraction that we're talking about. So there's boundaries because x cannot be 0. So that means we have to find out where does our graph have to stop. It comes close, but it actually won't ever cross it. So all we do is we say, okay, the vertical asymptote, it's going to go up and down. And the way we find it is we set the denominator equal to 0. So since the denominator is x minus 2, I'm going to do it up here in this quadrant. So we say this denominator, x minus 2 equals 0. All right, well then if we just solve it, that means x equals the number 2. That is our vertical asymptote. That is what we would call VA for our vertical asymptote. So we would go over to 2 and we would draw a dotted line. Okay? So that is the line that we're talking about. This is the line. This is the line that the graph will approach. It'll come close, but it will not cross it. So I'll show you the shape in a second. All right? Then, to get our HA, our horizontal asymptote, is x only in the denominator? If you look, yes. There's not an x up here, it's only down here. So when it's only in that denominator, it makes it a lot easier. So since x is only in the denominator, the horizontal asymptote is just that y is 0. So it's always that y is 0 if it's the only place that it is. Okay, so since y equals 0, because this is the only place where x shows up, that means it's just this, the x-axis. Okay, it's horizontal, so it's got to go across, crosses at 0. Okay, so it breaks it into 4 sections. Well, the reason why I wrote in this section is because it's not where the picture is. Our picture is actually in this corner and in this corner. Alright, and so if you notice, the line is going to come really close to this dotted line, but it's never going to touch it or never cross it. The line's going to keep going, but it's going to get really close, never going to touch. Same thing here. It'll get close, but it will never touch. And if you were to put this into your calculator, 4 divided by, put parentheses around that, you'd see it going in those 2 corners, and these are the boundaries. Those asymptotes tell you how close you get, but you don't cross. Alright, so that is how to get those asymptotes. So we're going to keep practicing that, and then talk about how to do, like, what is it? Pardon me. Our increasing and our decreasing intervals, plus our left and right boundaries. Like, what are we doing as we go to negative infinity? What are we doing? End behavior. That's what it's called. So let's look at another example.